All right, today we are going to be talking on nomenclature in alkanes. If you have watched my previous lecture on introduction to alkanes, you will understand that we've tried to get ourselves familiarized with the first 10 members of alkanes. And I told you in that lecture that it will form the background for nomenclature. Of course, you cannot start nomenclature if you don't have a basic background of the first 10 members of alkanes. Probably I will just recap, tell us their names, and then that will be a good background to start on. All right, with this nomenclature of alkanes. So we said we have the first 10 members of alkanes. So we have methane, we have ethane, we have propane, we have butane, we have pentane, we have hexane, we have heptane, then we have octane, we have nonane, and then we have decane. So these are the first 10 members of alkanes. We have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and then we have decane. In our last class, you refer back to that video. I tried to give us the structures of each of these members of alkanes. For example, we said methane is a 1 carbon atom molecule. Ethane is a 2 carbon molecule. Propane is a 3 carbon molecule. Butane is a 4 carbon molecule, and so forth. So as the serial number increases, the carbon length increases. And today we want to talk on nomenclature. What we mean by nomenclature is a system of naming alkanes. That's a system of naming alkanes. And the particular system adopted worldwide or all over the universe in naming organic chemistry structures is the IUPAC system of nomenclature. The IUPAC system of nomenclature. So all the names we are going to be doing here, we are going to be adopting the IUPAC system of nomenclature. And trust me, by the time we are done with this section, you should be able to find nomenclatures in alkanes very easy, or it will just be at your fingertips. Now, the best way to have a good background in nomenclature or naming of alkanes is to have this set of rules at the back of your mind. Yeah. When you can memorize these rules and you have every bit of the rule at the back of your mind, it will act as a guide towards helping you not to make mistakes in naming. And so the earlier we start getting ourselves familiarized with these rules, the better. So I will help us and make it easier for us as I go. I'll be giving us the rules, and I believe by the end of this class it should be a part and parcel of us. Okay, so let's now talk about nomenclature proper. So we will take an example Let's take an example of a structure. Let's say we are giving this structure to name. Alright, so we have a structure like this placed before us, and then we are asked to name this structure. Now, first of all, it will be confusing because looking at it is somehow complex. But hey, calm down, I'm here to make it more simpler for you. So at the end of this lecture, you should be able to name this particular structure and even much more other structures that have been a problem to you. So I can confidently tell you that by the time we wrap up this session, go back to your organic chemistry, pick those structures that were too difficult for you to name, and boom, you will start naming them as if you knew them from the onset. Alright, so let's go there. Now, what is the first thing you're supposed to know about nomenclature? Now, one thing you're supposed to know about nomenclature is that there is a rule guiding us in every step we go. And so I'm going to give us the first rule, and that rule is very important. In fact, I will say it is the most important rule in organic chemistry, because when you miss that step, you miss it all. And that rule is, whenever you see an organic chemistry structure placed in front of you, you should be able to identify the longest continuous carbon chain. The longest continuous carbon chain. Now, there is a concept, that is built up in the minds of those that are learning organic chemistry for the first time. And that concept is that the longest continuous carbon chain is supposed to always be in the horizontal line. That is very wrong. Now, there is no rule in organic chemistry as telling us you must count from this side to get the longest continuous carbon chain, or you must count from this other side to get the longest continuous carbon chain. You can start from anywhere. Yeah, that's the liberty you have in naming organic chemistry compounds. So you should know that you can start from the south, you can start from the east, you can start from the west. As far as the other principles and the other rules you're following are in place, you will name that structure. And somebody in the United Kingdom will name that structure. And of course, if you both has a very solid background in the principles of naming, you will see that you people will come out with the same structures. Yeah, you come out with the same nomenclature as to those structures. So the first rule there, the very first rule you should memorize now is always count the longest continuous carbon chain. Always count the longest continuous carbon chain. Now, I just told you that you can start from anywhere. And so someone in Nigeria can start counting this structure from this side and make this carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Now, I told you that that concept that you must count horizontally, it's very wrong. So I am seeing another carbon that is linked to carbon number 5, and that carbon is going vertically upward. And so, as a good organic chemist, I should be able to count to that aspect. So I should be able to make this carbon number 6. But someone who does not really have a good foundation in organic chemistry will definitely end here, and the person might now call the longest continuous carbon chain as pentane, and that is the beginning of your failure. It's becoming clearer, right? Let's move forward to make it clearer. Okay, so you see we have the longest continuous carbon chain here as 6, and of course 6 is related to hexane. 6 is related to hexane. Now, I believe you should be asking yourself, what if the other person decides to count from the right? I counted from my left. So what if another person said, oh, I don't want to start from the left, I want to start from the right? Fine, let's see how it goes. If someone is counting from the right, you see that you have this will be carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and then carbon number 6. So you see, we still have 6 counting from the right. Now, the idea now comes, which aspect do we count from? We have 6 from the both sides. So what are we now going to assume, or what are we now going to take as our longest continuous carbon chain? Now, you can agree with me that counting from the right, we have a carbon that we did not add in our counting at carbon number 2. Counting from the left, we have a carbon at carbon number 2, which is a branch. Counting from the right, we have the first branch at carbon number 3 rather. So therefore, what is the right thing to do as pertaining the rules in organic chemistry? Now, another rule come now, that you should count from the direction that gives you the first branch the least possible number. Count from the direction that gives the first branch the least possible number. And so, if I'm counting from my right, I have my first branch at position 2. If I'm counting from the right, I counted from the left, had my first branch at position 2. I counted from the right, had my first branch at position 3. So therefore, I compare these two. Between 3 and 2, which one is the least? Of course, 2 is lower than 3. And so therefore, this will now further tell us that, all right, this compound is supposed to be counted from the left aspect. So you can see we have a parent chain, this is our parent chain, and then we have basically 3 branches. So this is one of our branch, this is one of our branch there, and of course this is our branch, this is another branch. Now, in my first video when I was treating alkanes, I told us that there is a group called alkyl groups, and I was able to tell us how alkyls are derived. I told us that alkyl groups are derived from a loss of hydrogen from a corresponding alkane. So for example, if methane, which is CH4, loses an hydrogen, it becomes CH3. So now we remove ANE from methane and we add YL, and that turns to methyl. So you do it for subsequent alkanes. So for ethane, when you remove ANE, you get ethyl. And of course, instead of C2H6, you have C2H5. So that is how it goes. So here we have a methyl group. So we have a methyl group here. We have a methyl group here. So we have 2 methyl groups. Now, in naming organic chemistry structures, once you have one thing repeating itself twice, you don't call it 2 times. So we cannot now have methyl and then we have methyl again. It becomes childish naming it that way. So what we now do is add a di to the methyl, and that informs whoever is looking at that structure that, okay, we have 2 methyl groups in this structure. So instead of writing methyl, you can now write dimethyl. Now, will you just write dimethyl? Of course not, because the same person can still think, oh, does it mean that these 2 methyl groups are placed on the same carbon? Of course, we will put numbers in order to inform that person or whoever is looking at the name to your structure that these structures have the branches placed in different positions of the carbon chain. And so therefore, we have tried to note the number where these carbons, these branches are. And of course, our first methyl is on carbon 2, and our second methyl is on carbon 4. Now, note, we still have another branch at carbon number 3. And now that branch is much more complex. That's not a methyl group. Though it's an alkyl group, but not a methyl group. We have 2 carbon, and then we have about 2 carbon and 5 hydrogen. So you can see that this is C2H5. And I told you that this is actually from a corresponding alkane, which is ethane. So instead of calling it ethane, because there's lost one hydrogen, we call it ethyl. So we have an ethyl group. We have an ethyl group. So we have an ethyl group, and then we have 2 methyl groups. Now, there is one thing that we should know. In organic chemistry, we pay respect to alphabetical orders. We pay respect to alphabetical orders. So in arranging our branches, we make sure that we give respect to alphabetical orders. Yeah, so if we have a methyl and then you have an ethyl, we know that ethyl has 2 carbon, but comparing E, which is the beginning letter of ethyl, and M, which is the beginning letter of methyl, we see that E in the alphabetical order comes before M. So we are going to present ethyl first before methyl. So we have ethyl and then we have methyl. Now, of course, our ethyl is on carbon position 3, and our methyl is on, the first one is on carbon position 2, and the second is on carbon position 4. So by doing this, analyzing this, of course, we have been able to name our structure. It becomes easy. First of all, our parent chain is hexane. And then we have 3 branches, one on carbon position 2, one on position 4, and the other is on position 3. So therefore, how do we now order this in our name? Now, the parent chain always come at the end. The parent chain always come at the end. That is to tell you that this is a certain compound that is associated with this carbon number. So therefore, the parent chain, it's like the father of the house. Yeah, that is how I put it. The father of the house. The father of the house will always be behind to guide the children. So you see, the children will always come first. So take the branches as the children. So we name the branches first, and then the father of the house comes last. So we see, we'll now name all our branches, and then the last man of the house, which is the owner of the house, comes last. So the owner of this compound is hexane, and so therefore it will come last. So therefore, we're going to name this. We said ethyl will come first, and ethyl is on position 3. So we now have 3 ethyl. Now, another rule in organic chemistry is that while naming, you separate a number and an alphabet with a hyphen. For example, now I have 3 ethyl. You can see a hyphen between the 3 and the E. So the 3 ethyl, the hyphen must be there for that organic chemistry to be correct. That is the IUPAC set of rules, and you must obey it to the letter in order to get the correct name. So if I see someone coming to write just 3 ethyl, of course that is wrong. Even if you get the position where it is placed, and you even got the name of the substituent or the branch correctly. So we have 3 ethyl. We have 3 ethyl. The other branch that is there, it's on position 2. So we have on position 2, you have a methyl. We will not just say methyl, we have 2 methyl. So you put down the 2 positions where they are. So on position 2 and on position 4, we have on position 2 here, position 4. The same are the substituent or the same branch. So therefore, we bring them together. So we have 2 and 4. Now, you can note something that I did here. Between 2 and 4, there is a comma. Of course, in organic chemistry, there is another rule that you separate numbers with comma and the number and an alphabet with what? A hyphen, like I said. So therefore, we have 2, 4, and then this is a number to an alphabet, I do that with a hyphen. Dimethyl. Of course, I told you the principle of this di because there are two methyl. So dimethyl. And then the father of the house come, which is the owner of the house, hexane. There is no gap between the methyl and the hexane, so they are both together. So we can see that we have successfully named this compound as 3-methyl 2,3-ethyl 2,4-dimethyl hexane. 3-ethyl 2,4-dimethyl hexane. So in the moon, in the sun, at Pluto, in London, this structure will be named 3-ethyl 2,4-dimethyl hexane. We're going to take another example which will further enhance our understanding in organic chemistry. So we're going to take another example. Now, we're going to take this structure CH3, CH, CH, CH2, CH3, CH, CH3, CH2, CH3, then we have CH3. Now we have a much more complex structure as this. Okay, let me add something. This looks like the other. All right. Okay, so we have a much more complex structure. How do we now name this? First, we know some certain rules about organic chemistry already, so we apply those rules. The first of which is we try to count the longest continuous carbon chain, right? Of course. Now, that is the first thing we'll do. And secondly, you should know that you can count from all sides as far as it gets towards giving you the longest continuous carbon chain. The only rule that will limit you to a particular side is that rule that states that you count from the side that will give the first branch the lowest possible number. And so let's start our counting. I like starting from the left. So let's start from the left to count. We have position 1, position 2, position 3, position 4, 5, and then we have 6. Of course, it's continuous, so this is number 6. Now, someone can come and say, okay, what I want to do is count this direction. So the person makes this 5, and this is 6. Of course, that person is thinking. Someone can say, I want to count this direction, and you make this your 4, make this 5. Of course, 5 is lesser than 6, so we don't consider that at all. So we have 6 here as the highest. So is there any way we can count here to give us a higher number? Okay, one might decide to say, okay, let me start this way. Let me start here. 1, 2, 3, 4, 5, and 6. We still have 6. So it looks as if there is no aspect we want to count from as to get a higher number than 6. Alright, so having known that our longest chain contains 6, the question now remains, where do we count from? Because we've counted from different aspects and we are getting 6. So we are now confused, or rather you are now confused, and I will make it clearer to you that, okay, since we are counting from different axes and we're still having 6, of course, it is established that our parent chain is hexane. That is not in doubt. Our parent chain is what? Hexane. But then, what now becomes the side we are to count from? Where? Is it left? Is it right? Is it up? is it down? Because we've counted from up, we've counted from left, we've counted from right. Okay. We look at this now. Counting from the left, we have different branches which I will circle. This is our first branch. This is our second branch. And of course, this is our third branch. Now, our first branch is on carbon number 2. Our second branch is on carbon number 3. Our fourth branch is on carbon number 4. Now, counting from this side, we have 1, 2, 3. Our first branch is on carbon number 4. If we count from this aspect, we see that 1, 2, 3. Our first branch is on carbon number 3. So therefore, we see that counting from the left gives us a lower number where we have a branch, which is carbon number 2. And then we have another on carbon number 3. We have another on carbon number 4. So therefore, it now means that we will now count from the left. So therefore, we've been able to establish our branches. Of course, we've established that we have 3 branches. And we'll try to name those branches. On position 2, we have a methyl group. On position 3, we have an ethyl group. And now on position 4, there is something peculiar about that position. Now look at it. We have the number of carbon there is 3. The number of hydrogen there is 9. Or rather, the number of hydrogen is 7. So we have C3H7. Now, that is supposed to be from our principle of derivation of alkyls. It's supposed to be propyl. But hey, don't be excited yet. Now look at it. Propyl can be written as CH2, CH2, CH3. Now, if that carbon was attached, this CH, if it was attached on this carbon, we can call it propyl. But if you look at it now, it's attached at the central carbon. The CH is attached at the central carbon. So therefore, we are not in a hurry to call it propyl again. We now add the word iso to it. So we have isopropyl instead of the normal propyl, telling you that that is an isomer of propyl. So therefore, we have isopropyl. So on position 4, we have isopropyl. So we have been able to outline all the branches we have in this structure. First, our parent chain is hexane, and then we have methyl on position 2, ethyl on position 3, and isopropyl on position 4. So therefore, how do we now assemble these names? Of course, don't ever forget alphabetical order of arrangement. We have E here, we have P, and we have N. So therefore, our E comes first, our M comes, and then our P comes last. So therefore, we have 2-methyl, 3-ethyl, we have 3-ethyl, 2-methyl, 4-isopropyl, hexane. So this now becomes the name of this compound. We have 3-ethyl, 2-methyl, 4-isopropyl hexane. So I believe that with this set of rules and these examples we've taken, I've been able to improve your understanding on nomenclature in alkenes. As we go further to other aspects of organic chemistry, we'll continue our nomenclature series, and I believe by the time we are done with organic chemistry series, you should be able to beat your chest and say that organic chemistry is simple. For now, we are going to draw the curtain. Bye.